Hello guys, on behalf of Apache Solutions, I would like to welcome you to our today. So we've got an interesting presentation for today. Let me introduce myself. My name is Mikhail. I'm the Director of Curriculum Architecture at Apache Solutions. Apache is a training and consulting company offering training to Fortune 500 clients. So today's webinar is dedicated to Apache Airflow, which is an extremely useful and practical solution for managing your workflows. And today we will introduce the more important concepts so that you can wrap your head around what it is, as well as I will walk you through some code. There will be no demos, and I will be taking your questions as we go. Put your question in the questions pane. Yeah, there should be a detachable questions pane inside the console. If you would like to send me a private chat, please do. Just don't do it to the entire audience. Just send me targeted private chat. Set question to stuff. Okay, so let's get started. A little bit of introduction. So agenda is we will quickly talk about the traditional approaches to solving ETL problems and how Apache Airflow can help you in this department. We will review core components, and then probably more exciting for some of you would be walking through code. Traditionally, ETL is built around some of the existing solutions. It can be based around cron or ET or any other proprietary tools that you have in your data centers, in your data warehouses, data marts. So what you do, I guess you just have a script. Probably it'll be just a bash script or maybe PowerShell script, which will get the file that you want to get. It might be an FTP job, or it might be just wget or something. You bring the file, you onboard it, and then you start ingesting the data through a number of steps. Probably you would perform some sort of data cleaning, removing some outliers, some kind of a noise from your data. And generally that scheduled job would run every hour, every day, maybe every month, at the end of the month, and things like that. So the regular run-of-the-mill exercise that anyone who has been in IT for long enough was exposed to. So now the question would be, we kind of get kind of a more demanding for the traditional ETL jobs, and we can start asking such questions as, what about retries? So we would like to pull the data from a particular our partner's site, and for whatever reason it fails. Maybe they have a maintenance window, maybe the file is not available. How would you retry? Right. What about processing data and the data is not in the right format? What if on-premise locally we have a problem with the destinations, the sink for our data? What if our database that we are planning to insert data is down? So there's a myriad of possibilities that essentially can spoil our Friday's night just before going on a Saturday, I don't know, party route. Scaling. So usually you would have a script which essentially runs on a single thread of execution. What if we need to pull out data, I don't know, on multiple threads? So I guess if you have things like that, probably you would fall back on something that if you use Hadoop, Hadoop offers those tools in the form of maybe Apache Scoop, maybe Flume, maybe other systems which would help you to scale and just handle all those kind of things that normally you would experience, and normally you would just hope with your fingers crossed that everything would work fine, right? It's usually it's an ideal situation, and hopefully, I guess you have it all the time. I mean, kind of your luck has it always this way. Okay, and sometimes probably you need to create a custom script which would react to a file arriving in a particular directory. And again, systems like maybe Hadoop, particularly Hadoop, which has become probably a de facto standard for many organizations as a data lake, as a data warehousing platform, where you would have something which would handle all that kind of a thing through specialized scripts. But why not use just one tool, which might help you with the variety of situations? And Apache Airflow does exactly that. Okay, you can think about Airflow as a configuration as code, or infrastructure as code, or maybe workflow as code. Open source solution originally developed at Airbnb, and then they decided to donate it to Software Foundation. They use it in production themselves. It's not really a system that you would expect at being enterprise grade. It's definitely shows the signs of a homegrown solution, which is kind of has its own good things and bad things and ugly things. And so I'll kind of mention it. I personally, when I looked at it, and we developed a course around Apache Airflow, and I personally have an opinion. I've been in IT for more than 20 years. I'm an enterprise Java architect. I worked for banks, insurance companies, startup companies, and I've been kind of privy to lots of intricacies and proprietary systems, but Apache Airflow stands alone. It's kind of a thing which is kind of gives you a little bit of that kind of a free look at things. And at the same time, certain things just are not natural for those people who come from the enterprise background. But it does a job, and that's why we think that many companies would benefit by starting using Airflow, maybe on a smaller scale. So it's purely Python based. So you have Python installed on that Airflow worker machines, or on the machines in the cluster that Airflow would manage. There is no XML, YAML, or things like that. You essentially express your intent, your configuration of your workflow, the steps, the tasks, the connections, the relations in Python. If you know Python, that's it. You pretty much know Airflow. Right, and Airflow borrows all the ideas that fall under the category of DAG. It's a directed acyclic graph, which is essentially, it's not exactly like this, because DAG essentially doesn't allow you to do retries, but it's fancy term, everyone is using it. Why not drop this kind of a very kind of a sort of vague term at innocent people? So essentially, DAG is a way to support that kind of activity diagram, which would allow you to proceed with your workflow steps from left to right, or from right to left, whatever part of the world you are in. And I guess you would be pretty much responsible for everything. There would be no way to say, okay, guys, I own Airflow. I don't know anything else. I don't own. Airflow would be the code, and that would be essentially a place where you would be authoring, executing, and using to monitor. And in many cases, Airflow has started kind of getting traction with enterprise people by replacing traditional ETL tools. Usually it's just positions, it gets positioned as a replacement for cron. So core components as follows. We've got scheduler, which is essentially a process. By the way, Airflow runs without any modifications only on Linux. On Windows, Windows doesn't have some of the components. You have to customize your environment, but that bespoke solution might have some problems. So the best way, and that's where I guess it was designed for. Because again, as I said, it was born out of the necessity. Those people at Airbnb, they wanted to find a solution which would kind of cater to their in-house needs, and the platform of choice was Linux. So schedule is a process that you start, and that essentially would perform all the scheduling activities. The executor is that component which actually performs the actual execution of tasks. Web server, it's the web UI, nice dashboard. I will the slide. There will be a couple of, or maybe a couple of slides showing you what it looks like. It's just kind of a breeze, nice to use, and very responsive. Everything is written in Python. So, for example, Flask is that platform as kind of a toolbox which allows you to use Python to quickly put together the components, and web UI is very nice. And metadata database, which actually keeps track of all your DAGs, of all your pretty much workflows. By default, it comes with SQLite, which is single-threaded. It's limiting. But it's great for prototyping and probably for small to medium type of workflows, not very demanding. If you want to roll it out in production, probably you would need to go with MySQL, Postgres, and other databases. As long as, I guess, Python can talk to that database, and Python can do, it's a polyglot database language. So this is a collaboration diagram. I'm not going to go through all that, but as you probably touched on some of the things, we've got nice scheduler which sits at the core, at the heart of the whole thing. You can store your DAGs in database or file system, and there is a pool that essentially would allow you to scale your solutions, and those DAG files, which are Python files. These are regular Python files that you can create in of your editor of choice. The building blocks for workflows. So DAG is the abstraction which essentially defines your activity, your workflow, which would consist of tasks, and those tasks would essentially be backed by operators. So those operators are workers which can be scaled from the worker pool, and those are Python functions. You define those. There is essentially a class like Python operator or Bash operator or any other types of operators that you can flesh out with your code, and that would be the unit of work. Essentially, that would be the task executed. You can retry a task, and DAG defines the relationship. So where do you start? Where is that point, kind of a big bang? So where the data arrives? How would you clean the data? What would happen if you need to retry getting the data? And then processing data, you can have business logic built in. Of course, don't go overboard with trying to squeeze in as much logic as possible in the operators. Definitely, it's not a good thing, but essentially, it can do quite good service for you. It probably not designed for kind of heavy lifting in this regard, but business logic can be incorporated, particularly when it comes to cleaning the data, removing outliers, things like that. Okay, so critical thing, task is a job which is performed by operator, which is the Python code, and DAG essentially binds everything together. A good thing is that you can have out of the box a variety of connections and hooks, which is essentially abstractions of some of the external systems. So you can connect to a cloud provider, be it, for example, S3. You can use a variety of access points. You can perform configuration. All the tokens, access, and all the credentials can be managed. It's quite a sophisticated system in this regard, right? Internally, you would most likely use, if you are not using connections or hooks, you can probably create your own if you are not satisfied with that quite impressive list of the existing supported external systems. XCOM, it's a little bit kind of an in-house thing. It allows you to build the messaging. So what happens when that task gets executed. Essentially, it's an isolated, I don't know exactly, but it looks from kind of our experiments, it looks like it's just a Python Python job, and which runs on a separate Java Python runtime. And in order to exchange messages, exchange data, it's not like you just return a value and you somehow read the value. All those operators or tasks, they will be isolated. And in order to exchange information so that you can share the state, you would need something like PubSub, like messaging middleware. And XCOM, cross communication facility, is exactly like that. So there will be an example for you to see how things are done. It sounds kind of very sophisticated, as if, I don't know, it just goes through satellite somewhere and then sends a message encrypted. No, it's just plain vanilla. And they are using internally some of the messaging platforms, also open source. And you can publish your messages and you get the data. Only this thing can actually give you a great deal of flexibility. It allows you to avoid, essentially it will be done synchronously, but it's just a way to decouple things in some way. You can develop, test, and evolve your system independently and not kind of cursing under your breath if something doesn't go as expected. Command line, everything is built around that. So that's where you would be, I guess, getting your hands dirty. Airflow is a primary tool, right? So Airflow, it's a script which essentially takes commands, and those commands take arguments. And here's an example of what you can do if, for example, a particular DAG failed and it was a mess. And you would like to clean all the previous runs for past period. So that's what you would be able to do. So essentially, clear is the command, and all the arguments would essentially be specific DAG is ID for the DAGs that you want, because every DAG essentially is identified, and you will see it shortly. Start and end date, essentially that's a range of the dates where things just didn't work as expected. Probably you got an alert. By the way, Airflow supports alerting, and someone is not happy, shouting over the phone. Probably this guy is really frustrated that they didn't receive the data. So you just need this thing, and then you would rerun the DAG. So main processes are two. So that's how you start. Scheduler, you can start them in this order, and that's the recommended one. If schedule is not up and running, web server would, I don't know, kind of notify you about that. By default, there are 4 worker processes. That's the pool, so that they can handle requests in parallel. And so scheduler would, in collaboration with web server, essentially would contact the directory where there is a specific directory, Airflow DAG directory. It's kind of the workspace where you would have your Python scripts, which contain DAG definitions. And then it would just find the DAG IDs that you want to schedule, and it will just take it out of the worker out of the pool and schedule the job to run. Right, and scheduler tries to be be in control of things. You can have multiple web server processes. And by default, it starts listening, I believe, at port 8080. It's a very popular port. Everyone is using it, Tomcat and other folks. But this is Flask. This is Python. So when you get the first hit, you will see you can suppress it. It's just all the DAGs that currently come from the examples directory. It's another directory which you can suppress, but when you get started, just keep them around maybe for a month to see. They might not help you very much, but I guess at least it'll give you a comfort. Okay, we've got this thing. So right up front, I can give you a couple of hints, because when I started, it was so frustrating because you expect, and I guess over time, you essentially develop this attitude that that the system should kind of work without explaining how to operate it, right? So that you don't need the manual. It's stupid. I agree. I'm kind of I have sinned further on that thing, but you just sometimes people have a different perspective on things. You need to essentially, if you look at this kind of a UI, it just says that's the way to pause your DAG. Okay, DAG should run. You can pause it, right? Currently it's off, meaning that it's already kind of available for you. So the door is open. But in fact, contrary to what you would see on that eye, if you hover your mouse over, essentially it's the opposite. Anyways, I don't want to complain, but it's interesting that I haven't seen many examples, and most of them they just don't mention it. I had to kind of walk through some of the kind of YouTube thing and see how actually the guy is just clicking. Okay, let's click it, blah, blah, blah. Okay, what did you just do? Okay, I put it on pause. The guy turned this on. So I'm sharing with you this thing. And you just click on that arrow play button. That's the way to trigger. The triggering means you can do it manually like so, or you can have it scheduled. And scheduling is a beautiful thing because the schedule is shown here. They support the cron-like scheduling, like every second minute, every minute, or they have those macros, which is essentially commands understood by Python, like daily, hourly, and there is a third facility where you can use just date time object to configure very sophisticated scheduling, right? But cron, if you kind of the cron staunch supporter, you can use that scheduling. You can provide the owner, which would kind of assign the blame. Currently it's Airflow. You can have your own companies, your QA, or I don't know, SIT, or whatever integration environment you have. Actually, it will show you the state of the DAG and all the recent tasks in special colored scheme where you would have different colors for the status. Your task might fail, or it might be successful, or it might be suspended because of the previously failed tasks. Okay, that is the most important three, I guess, touch points. I'm referring to those links. Very nice, very responsive. No, actually, it's not very responsive because it needs to communicate with the scheduler. But when everything works fine and you kind of the system is up to date, it's quite responsive. You have very nice visuals. So this is a tree view, the graph view, and the code. So you can see the code of the programs that is being executed, and you click on that trigger DAG thing. Okay, so that's it for I guess just overview. And now let's kind of take a look at what it actually looks like. So we will start, by the way, so we developed this today class, which essentially walks you through multiple examples showing how to do it. And what's interesting, you essentially can copy paste and use those scripts in production right away. We are using the latest, greatest version of Airflow. Let me highlight a couple of things. How can I do it? Spotlight. Okay, so this is a DAG. DAG is essentially a reference. This is Python code, right? They even specify that the dependency using that they override that bitwise operator, which essentially tells you that T2 depends on the T1 job, which is upstream job. And you can have very sophisticated flow. You can, by the way, have multiple branches here, but just let's not go there. So in Python, everything gets executed from top to bottom, right? So DAG is instantiated. You provide ID, you read the arguments. By the way, start date, I don't want to go there. It's just a totally, I don't know, misnomer. It looks like they started with an idea in mind, and then they evolved it, and then it just lost. There is execution time and the start time. And that's where I guess most people get tripped. Essentially, it's the reverse. That would be the execution time, and that execution time should be the start time, except for the backfill, because backfill essentially does things in the retrospect. But we will touch on that point later on. So days ago, it's just a function which essentially says, don't go back. We don't want to execute jobs from the past. That's kind of probably something that you would be tripped over and over and over again. So there are solutions that we offer in the class. So we read the default parameters and we say, we want this thing to be executed just once, okay? Once. So meaning that when you click on this thing, triggers a DAG, it would run once and the output would be produced, be it, so outcome can be a failure, problem with actually running the code, it might be syntax error, Python does not get compiled, you have to essentially wait for that problem to happen, unless you have some testing harness around it. And so what happens, we're using the bash operator. So there's a Python operator, there are like a simple SMTP operator, all this stuff, quite broad palette of those operators. So what we do, we're using bash, so it runs on Linux, and it would invoke the bash, the script. And what we're doing here, I guess it's just a combination of your regular code. This is a way to take a date, convert it to a string. This is Python code. And then we start building the command for bash to execute. It just shows you that essentially you can plug in, for example, date in a specific format. This is the way, this is kind of a syntax for the C languages, C language formatted string date function. It's just a very popular one. And then you can execute it in this way. So when you do, we do this string interpolation, we pass on now and system, and that command actually is borrowed from one of the lab. It just gives you the insight into the inner workings, because all the examples that we can, most of the examples, I don't know, I haven't seen many, they just essentially, hey, hello world, look ma, it works, right? No kind of no problems. And in many cases, it's probably not very useful. So we also specify the dummy operator, which is essentially a placeholder. If you start kind of building, start organically grow your workflow, you would probably need to plug in the dummy operator, which is probably a good way to say, okay, this is plug, doesn't do much, but it just helps us to reserve a place for this. As you see, every operator has an ID, and that's how you would be able to track those tasks happening here. So if a particular task fails, you will see the ID and which task fails. Okay, so so that's it. So what's going to happen now? When this line is reached by the interpreter, when you schedule, Python will essentially execute the whole thing, and it will just instantiate the required runtime support, and then that bash would essentially be scheduled to run on the machine, on local machine. And what it will do, it essentially print. And once this bash command is executed, it is also gets an imprint in your log file. So you will see this message. You can also return a value. That's another thing. And if you would like to pass a message, you would need to use XCOM. Okay, so so that's it for the bash operator. Now backfilling. So they position backfilling as if it's just they can travel back in time. It's just I guess a little bit childish, but essentially that's how they just position it. Okay, we can go back in time. But if you really start looking at it, okay, how can you do this? Is it time machine? Or is it I don't know, Herbert Wells? Or who is actually who have you I don't know, hired as a consultant to travel back in time. Essentially, they just generate timestamps that you can, the execution timestamps that you can plug in and build literals, which could be executed as commands. So let's see what happens. As you see, we start with 0. It's kind of a safe bet. Everything would happen actually when you invoke that backfill command. We would essentially say, we would like to complete the previously unexecuted or failed. Remember that clear DAG, that's the way to say, okay, I'm discarding all the jobs because we didn't get the results we wanted. We wanted it again. Hopefully that the job would be important. So we perform that range from start to end. And what's important for us for the backfill process to work is that we need to specify the interval. The interval is 24 hours, and we should define it somewhere in DAG. Okay, here we go. It's 1 day. I guess you can use cron for that, but I guess that's the way, I guess the preferred way. Cron is sort of kind of a get people on board, kind of say, yeah, we understand cron, but in fact, you would be better off to avoid cron because at a certain point in time, it would just be confusing. And that time delta thing of the datetime object of Python really does the job. You can actually schedule it to run at every microsecond if you want to, which would be probably not very useful. So what essentially this code does, ZTS node dash, it's so-called macro. So they're using this macro language similar to, I don't know, like JSP, if you are familiar with that. It's kind of a Gingy macro language. Essentially, it would encounter, when the interpreter would encounter this double arrow thing in code, it would essentially replace it with value. This is the execution time. But what's interesting, it's kind of a TS, kind of a starting time, but in fact, the execution time. That's how they position it. But it has kind of a still carries that history of that start date. No dash means that it should avoid the dashing in the date. That's it. So if you look at it, it would be kind of a year or months, just to kind of with no spaces, with no dashes, just one blob, kind of a club. And then that file name would essentially be constructed as per. Again, this is borrowed from our lab in the course, and just a way to say how you can build it. This is a practical way to actually harness this backfilling process. And then this was timestamp for execution, and this is the date. And so that's how we create a bash command. We perform first the touch. Bash would essentially run 2 commands, touching the file, and then creating that pseudo SQL engine command, which would be built around SQL time and file name, and then you can have another job which essentially would take this SQL and it would schedule it for execution, right? And so the generated SQL, that line, would be something like this, right? With timestamp, SQL time dash execution time. So that's no dash. You see, it's just the year followed by the month and followed by the day. Okay, and then we execute this. We provide a reference to the DAG, and then it would do the whole thing. Okay, so what you will have so many files. Each would correspond to the date, except for the last one, which is another pet peeve. Why they do it? It's another story, but that's kind of a feature. You can actually roll up your sleeves, go, this is open source, and probably influence those people to change that behavior. But that's how it is. It works. Just be aware of this. Just add another day, and you will be able to cover the whole period. It's kind of off by one, and you will be kind of bumping your head against this wall over and over again. So that's, I guess, it. XCOM communication. So generally, when you see those small pitfalls, kind of gotchas, if you kind of say, okay, I understand what they are now, you kind of become really empowered. You would pretty much be running a very sophisticated workflows from a single machine in a very efficient way, in a secure way. You would be able to replace a number of tools that you're currently using. And you can express your logic using Python, which in itself is a very powerful language. You can, I guess, add maybe data science, machine learning things if you want to, so that you essentially would be learning from the data that comes in. So in the XCOM communication, you have 2 parties, the sender and the receiver. You can have multiple receivers. This is kind of a pub sub type of communication. For XCOM, you are better off to use Python operator, even though you can use Bash operator as well. You just need to provide a specific parameter indicating that you would like to send that response, that kind of return value as a message. So Python operator is your safe bet. You specify ID. What's important is to provide a context. Context is just a dependency injection where that function that is callback would receive that keywords. It's a dictionary, kind of a map, key value pairs, and it would contain everything that Airflow sees at this juncture of your flow. Essentially, it's just a bunch of system information, and a couple of things are quite useful. And what's interesting is that during this injection of the context, you can specify some of the parameters by their names. So this is a variable name, which is essentially which is included in those dictionaries, in that dictionary. So the double star means that it's just key value. It's not a pointer or double referencer or something like that. It's just a Python's way to say, hopefully you understand Python. I kind of assume that the reason you are on the call is that you would probably know something about Airflow. So TI is just the reference to itself. It's kind of a pointer to itself, that this pointer, right? You can actually get it in this way, getting the task instance as TI. The TI is just shortcut. So what we're doing here, just ignore this thing. We are building a message. We need to provide a message key, which is a string. It can be, I guess, a number, but string is a safe bet. And you're pushing the message. So this task instance, or you can use TI. That's me, kind of. That's this. That's the context in which I get my DAG gets executed. XCOM push is a method on that instance available. And key would be message key, and the value would be actually the message. And message can be kind of large enough. And that's it. And by the way, that would be just one way to send a message. Also, by default, the return value from a method, that Python method specified in the Python operator, would also be part of that communication, right? It's kind of something that is given by courtesy of XCOM. Kind of a very good thing. That's kind of a practical, and that's now you kind of see that people created it for themselves. That means that they just didn't have to go through all the, I don't know, that arbitration and that a committee that would review all the specs and say, no, it's not elegant enough. We should kind of do something that I've read like 20 years ago in a book somewhere. It's very practical. It's very down to earth, and that's the beauty of it. And the receiver, right? So we send a message, and that message essentially should arrive somewhere, or it can be published and sitting somewhere. And if nobody is interested, it will be just dying without getting noticed. And the Python operator would also specify the context to get hold of that dictionary, and the receiver handler would be the callback, which would be instantiated when this Python operator is evaluated. So what we do, we get a reference to that this task instance, which is the pointer to itself, and we receive a message, and that's how we get it. Again, there is a XCOM pull and a push, and the XCOM pull. We specify the ID of that sender, right? It's kind of where it's sort of that pops up topic where I'm interested. That's what I want to do. And the key. If you don't specify the key, it would be just a way to indicate that you are interested in all the messages, kind of promiscuous approach, right? And also you can read the return value here as well. Okay, so do try and catch, because sometimes you might have a problem. It's a good kind of clean way, and you can do logging error. By default, that print functions, whenever you see this is put into the login.info. Info, that's the Python's way to do logging, and that system is shamelessly borrowed from log4j system of Java, and that's kind of the right way to do things. Don't reinvent the wheel. Log4j is a great system. You cannot achieve everything in Python, but that's just a good way to, I guess, leverage other people's work. Okay, so that's pretty much it, what I wanted to tell you about Apache Airflow. And we've got some time for any questions that you might have. So this is a 2-day class, and essentially it has, I believe, let me just walk you through this quickly. For that, I need to change my sharing, right? Just give me a second, guys. So, where is that thing? Right. So it's a 2-day class. It's a good idea that you are familiar, should be familiar with Python syntax, at least to understand. Don't to be scared what it is, right? It's very kind of a light on theory because essentially it reduces very quickly because you would be able to understand how things work by going through the labs. And we've got 12 labs which essentially would dissect all the aspects, except for some of the advanced topics, which would involve some sharing of security credentials, but you would be able to figure out how actually they work. You will be dealing with some of the kind of aspects like using some of the global variables, how to change variables, the context, how to configure some of the operators. The user retries, very practical, so you would be able to essentially copy paste and use them in your production environments right away. Okay, I don't see any questions, guys. Again, put your questions in the questions pane or in the chat. Okay, guys, going once, going twice. Okay, it looks like you new to Apache Airflow, and probably this presentation of mine was just enough for you to get, I don't know, get your interest, and it would probably be worthwhile for you to just, I don't know, download Apache Airflow. Again, you would need for that probably a Linux virtual machine. Just set up Ubuntu, that would be fine, or maybe CentOS, and try it for free. Experiment. As I mentioned, there would be some very annoying kind of I would say mismatch or impedance mismatch or cognitive gaps, if you will. And it's not natural in some cases, but once you're out of the woods, you would appreciate the system because it was created by good professionals who use it in production. Many people do. By the way, one of the angles why we decided to develop it, we don't have, by the way, very many people on this call. And the rationale was that it supplements our portfolio of the learning products in the area of data engineering and machine learning. It's just a natural fit. Everything is just in Python, and in many cases, you can build processing pipelines using Airflow. Of course, you can use other tools, and many machine learning and data science tools, they use what's called a pipeline, where you can have multiple things stitched together, but those are more specific for the actually final step, where essentially you do the training of your model, feature selection, and selection of the model with different hyperparameters. But this one, this tool, this software actually does a job before that, where you would be in the realm of data engineering. Okay, so this is the context of things. Okay, so the question is, you mentioned this is an ETL and workflow tool, but this is a bit different. Can you explain, clarify? Yes, ETL generally essentially it's extract, transform, and load, right? In many cases, you don't even have a transform, you just extract and load the data, right? But in ETL jobs, that's plain vanilla ETL. Just don't do anything. Just get that dump and put it in on the system. Like ETL essentially is just a two-step workflow. You do extraction and you do the loading, right? If you kind of go on a very, I would say, on the academic level, I agree, Brian. That's kind of different things. But essentially, if you start taking a more pragmatic, kind of down to earth, maybe less stringent definition of ETL or workflow, you could say that ETL essentially it's a three-step workflow. Or in many cases, as I said, like if you have a NoSQL like Hadoop, you would only have extraction and loading, meaning the transformation would be done through schema on demand. Okay, so you're right. That's kind of my point, but you can, I guess, argue both ways. Usually a batch no ETL is a batch, right, but it doesn't matter if you can schedule workflow to run as a batch as well, right? Batch is unattended thing that runs over a period of time. Workflow is somewhat that the user, yeah, I just reading your question because I just got going on the first thing. The workflow I have GUIs and everything. You can argue both ways. If you use cron, definitely there would be no UI. But if I guess you take some more sophisticated ETLs tools, you can find that there are GUIs. And yeah, but you're right. So if you go at this angle, absolutely. But I would say if you are just looking at the workflow, low-level command line thing, they would be probably very close. Okay, thank you, Sarah. Sarah's gone. Okay, what's the Airflow dynamic pipeline and how briefly does it work? I'm not familiar with this thing, dynamic pipeline. Dynamic means, yeah, you can change it. I guess you can do branching, for example, if that's what you mean. But branching is a way for you to actually perform. I believe we do the lab for task branching. Essentially, it would be dynamic. Yeah, probably that's what you meant, right? So depending on the context, the value, and of if you want an example, let me just bring up. I've got this thing somewhere sitting on my laptop, branching, right? Yeah, yeah. So I'm referring to this lab, Brian. Yeah, just give me a second. Or was it James? James, yeah. Yeah, James, just give me a second. What I need to do. So the question is, again, guys, what's the Airflow dynamic pipeline and how briefly does that work? In the most kind of a brief way, it would be just to show you probably that the DAG, right? So that's what you do. Essentially, you have an event generated by an external system. This is a signal to which a broker, which is a component, reacts. And then you have a very, very simple kind of a dichotomy, kind of a binary choice, buy and sell. Essentially, this operation simulates a broker action to buy or sell. You can add a third, like hold, or maybe some other action activity. So essentially what happens is that you have code, and that code is a decision maker. So that branch Python operator has a decision maker. And what it does, broker is, by the way, is actually that branch task. Decision maker, if you go through this method, it's not method, it's a callback function. It would receive, it would pull an event, and it will start looking at the event. It will unpack it, and there would be very basic logic. I believe there would be a time of seconds. So essentially, it would just emulate binary choice: buy if it's below in the first half of the minute, and then sell if that's the other one. Kind of a sell at the end of the day. Sometimes this logic works, right? So that's hopefully, James, it answers your question. Guys, more questions? Okay. Okay, guys, thank you for your interest. And looks like maybe a couple of you got the answers, what you were looking for. Again, thank you for attending, and happy programming. All the best. Bye bye.